Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at our fourth question from the 2018 Manitoba Math Competition. We've got an A and a B part, so let's get down to it. Determine the sum of all 5-digit numbers whose digits consist only of 2s or 3s. Alright, there's going to be a lot of numbers that do that. And we really don't want to write them all out. Now, if it were simpler, if it were smaller, you could do something like, if it was just 3 digits, you could write all those out and probably add them up. Okay, so I'm going to write them all out just as an example for how I'm going to explain how we think through a problem like this. So there we go. There's this many, and that's all you're going to have. And you might notice, oh, there's 8 of them. Now, you don't need to know that there's 8 of them in order to just add these up. But why is there going to be 8 of them? And when I do just 2-digit ones, why is there going to be 4 of them? And why will there be 16 when I look at 4 digits? Or why is there going to be 32 when I look at 5 digits? Well, the way it works is when we think about how we make our 5-digit number, because it's 2s and 3s, you can have either one in any position. It'd be different if they said some of all the numbers, 5-digit numbers that use 5s and 0s, because 0 quite specifically can't be a leading digit. Otherwise, you wouldn't call that a 5-digit number, you'd call it a 4 or a 3-digit number, depending on how many zeros you had. But with 2s and 3s, they can be in any position. So I can have all 2s, I can have all 3s, I can have any mix in between. So here's how we think about it. How many choices of digit do I have for the first position? And there's going to be 2 of them. Now our choice of digit, either 2 or 3, doesn't affect our next choice. So in the thousands position, there's 2 choices again, a 2 or a 3. 2 choices, 2 choices, and 2 choices. And because these choices are all independent, if we want the total possible number of numbers, you're going to get 32. Okay, so that's how I know the number of numbers. But how are we going to figure out the sum? Well, it's the exact same sort of reasoning. Okay, imagine the numbers, the 5-digit numbers that have a 2 in the tens position. Right? How many other numbers can we have? Or how many numbers can satisfy this? Well, once the 2 is fixed here, there's 2 choices for the first one, 2 choices for the next one, 2 choices for the hundreds position, and 2 choices for the tens digit. There's going to be 16 numbers that have a 2 in the tens position, and the other 16 of our 32 are going to have a 3 there. And this is true for everything. How many of them have a 3 in the thousands position? 16, because there's 2 choices, 2 choices, 2 choices, 2 choices. Multiply them all together, 16. We don't get a choice for our thousands digit. Okay? And many of these 2s on screen are not digit 2s, but 2 choices. Just the ones in boxes are the ones that are fixed. We'll fix this one here. Okay? So, alright. Suppose I wanted to add up all these numbers. We don't want to make a giant list and count them all up, although you could. You could get 32 numbers and add them up, but that's going to be a waste of time. What you could instead do is say, okay, let's add them up as though we were going to write them out in a big column like this. We're going to add up all the ones digits, and then add up all the tens digits, and so on. So here's what we're going to get. If we think about the ones digits, 16 of them are 3, and 16 of them are 2. So if we were just adding up the ones digits, we'd get 16 times 3 plus 2 is 5, and that's going to be 80. How about, so this is the ones digits, how about the tens digits? Well, again, 16 of those 10 digits are going to be 3, and 16 of them are going to be 2. So the sum of the numbers in the tens digits is also 80, but we're going to multiply that by 10 because it's not technically adding up 20, it's really adding up, it's not really adding up 2, it's adding up 20 because you got a 0 in the ones position. Okay. How about if we just added up the numbers in the hundreds? Well, there's going to be 16 threes and 16 twos, and that's a total of 80. But we multiply that by 100 because we're actually getting 16 300s and 16 200s. And we just keep going on like that. So you'll get 80 times 1,000, and finally 80 times 10,000. And this is what we want to add up. So we'll get 80 times 1 plus 10 plus 100. If we add those up, we're going to get 11111. So 11,111. Okay, so what do I do? Well, this is 8 times 11110, and then bring the 8 in. Oh, need one more. And our final answer is going to be 888,880. Okay, it's not the only way to explain it, but it is important to be clear where these numbers are coming from, adding up the ones digits, adding up the tens digits. You do want to write something intelligent. You probably don't want to just list them all out and add them up, although I'm sure some people did. I'm sure some people did in the course of the question. Anyway, we don't want to be like those people because that wastes time, and then we don't get on to questions, 7 or 6. Okay, so let's take a look now at 4b. A sequence of real numbers is defined by x0 or x0 is equal to 1, and xk plus 1, so we're defining it recursively, is 2 times xk minus 4 over xk plus 2. Determine the value of x 2018. Okay, so as usual for a sequence question like this, or really any, I guess sequence probably is the best way to do it, but best way to say it. But with a question like this, where they're asking about this specific thing, this term, this function, this picture, this grid layout or something, with a really, really big number like 2018, odds are it's not because 2018 is special. I mean, sometimes that happens, and it's important to know things like, is the year of the contest prime? Is it a perfect square? Is it a sum of two squares? That sort of a thing. Okay? But in this case, my strong suspicion is that 2018 isn't really that important. It's just supposed to be a really big number. And that's a hint to us that we should take a look at the first few terms and see if we can work out a pattern. This is going to be a pattern recognition question. Fairly certain of it. Okay, so let's start writing out terms. So I know x0 is 1, and then xk plus 1, so the next term, 2 times the current term minus 4 over the current term plus 2. I think that's correct. Yes. Okay. So, I think it might be easier for me if I just take out a 2 on the top. Anyways, there we go. So what would the next term be? We'd have 1, then we get 2 times 1 minus 2 over 1 plus 2. That's going to be negative 2/3. Negative 2/4. Oh, no, it is a 2. Did that thing where my hand is moving faster than my mouth. And my brain had it worked out, and it is a 3 down there. Okay, fantastic. So now I know the next term. 2 times negative 2/3 minus 2 over negative 2/3 plus 2. All right, let's get a common denominator. So negative 2 minus a 6 over 3, negative 2 plus a 6 over 3. So that's 2, negative 8 over 3 over 4 over 3. We're looking at negative 4. It's 2 times, it's again, there we go, 3 there. But the 3's basically cancel out. Whenever you divide by, if you do something like a over c over b over c, that's just a over b. You can use that as a nice quick shortcut. So our terms are looking like 1, negative 2/3, negative 4. All right, not noticing any particular pattern yet. Let's get a little space and see if we can get the next one. So the next term will be 2, negative 4 minus 2 over negative 4 plus 2. And that'll be 2 times negative 6 over negative 2. And that'll end up being 6. So we multiply by 2 times 3. Okay, so it's positive again. Alright. Really not noticing a pattern yet. Let's give it one more. 6 minus 2 over 6 plus 2. That's going to be 2 times 4 over 8. And that's going to be 2 times a half, and it's 1, and we're back to 1 again. And the cycle, it'll cycle around, it'll repeat, because your next term only depends on your previous term. So if you ever hit 1 again, I know the next one will be negative 2/3, and the next one will be negative 4, and the next one will be 6. Okay, great. So pattern repeats. Every 4. So 2018 has a remainder of 2 when we divide by 4. How do I know that? Well, I take a look, I ask, are the last 2 digits a multiple of 4? Oh, they're not, so this isn't a multiple of 4, but it's even. An even number that isn't a multiple of 4 leaves a remainder of 2 when you do divide by 4. That's how I was able to do that. No calculator required for that sort of thing. So x 2018 is equal to x2, which is negative 2/3. And that's going to be our answer. Okay? Incidentally, the rule that we have, we can write it like this. Xk plus 1, 2, 3, 4. Yeah. Xk plus 4 is equal to xk. In fact, I think we could probably even prove that. I'm not entirely sure. Yeah, I think it would take a little, not a little bit of time to try to prove it, but it would take a little bit of writing to prove that. But it's something to go ahead and try. You can make functions like this. I think this is something similar to a Mobius function that you might see in like a third-year math course. And they are sort of cyclic. They do repeat. They're quite nice and neat. But as long as we understand the pattern, as long as we have that second term correct, we're good to go. And that finishes off question number 4. In the next video, we'll take a look at question number 5. Thanks for watching. I'll see you there.